Well, welcome back, everybody. Hope you had a good spring break. I want to first, we're going to go on today looking at, let's see, it's chapter 5, I think it's 5.3. It's, what course was this? Spring break, you know, it all goes every month. On recursive definitions, section 5.3. But before I do that, I want to look at this one problem on the exam that I graded and kind of go back over a common mistake. If you go back and look at chapter 1, it tells you, I remember, and I tried to, well, I guess I failed, but that it's really common to get the contrapositive and the converse and inverse, get those mixed up. And that's what happened to a lot of you. Let me show you what happened. So here was the if x and y, here's the problem. X and y are irrational, and that implies that x minus y is irrational. Now, I didn't ask you to prove it. That should have been a clue. Prove or disprove, I said. So that's a clue, that's a hint. Oh, maybe I should look at both cases, you know, if it's true or if it's false. And it's okay to start proving it and realize, and I hope you would have hit a roadblock, because let me show you what would have happened if you'd gone through it correctly. Many of you tripped up on the following. So this is P implies Q. Okay. Well, the contrapositive, remember, is not Q implies not P. So let me write this out in full. So this says, and some of you started by writing this, x and y rational implies the negation of x and y irrational. Well, the negation of this is not that x and y are both rational, right? It's De Morgan's law. It becomes an or, right? So this is the same as x not irrational, which means x is rational, or y is rational. Not that, but you know. So at that point, you realize that you get stuck, I hope. Okay. What I did see a lot of you do, though, is not even get to here. I saw a lot, unfortunately, went to this route. Some of you started with this and then said, okay, let's suppose x is a ratio of a over b, and y is a ratio of c over d, and then that means x minus y is a ratio of integers. So you said this, but then you proved it backwards, which is then proving this. Okay. But this is different. This is the inverse. It's not the contrapositive. This is the same as this. This is not. So this is the statement. Again, not x and y irrational implies, whoops, I got it backwards. Wait, where am I? Oh no, I'm a little irrational, sorry. So yeah, here's P. The negation of that implies that the negation of x and y irrational. And here you get stuck real quick too, I would hope, which should be a clue. This is, x is irrational, or I'm sorry, x is rational, so x is not irrational, so x is rational, or, so the and becomes an or in the De Morgan's law. Y is rational. So if either x or y are rational, then x minus y is rational. And even if you form this, you get stuck real quick too. Because it's an or, and how do you do that? You'd have to. That's very difficult to deal with in this implication. So, so hopefully with this you realize you could get stuck. And you remember I tried to explain this. Remember the example I gave you real early in the class. Let R be, I walk in the rain. Okay, without reindeer. There's no reindeer. And let W be, I get wet. Right? And the statement, if I walk in the rain, I get wet, is R implies W. And if we work out the truth table for this, R, W, okay, so it's false, false. Let's just see, you know, when is it that I get wet? This becomes true, true, false, true. So this statement, if I walk in the rain, then I get wet, is false only on one condition, it's raining and I'm walking in the rain with no rain gear. That's the T. That's R. But in fact, I do not get wet. So if that case could hold, then this statement would be false. If we negate W and negate R, okay, so this is the contrapositive. If I don't get wet, well, what can we conclude? We can conclude I must not be walking in the rain without rain gear. That's the contrapositive. You can guarantee, if this is always a tautology, let's suppose that R implies W as a tautology, it's always true, then this becomes always true. Then if you see me, not wet, then you can guarantee I'm not walking in the rain without rain gear. Right? So this becomes, and this is the, so let me look at this truth table, T, F, T, F. Okay, and not R is T, T, F, F. And then not W implies not R is the same truth table, right? Because it's only false in this one condition where the hypothesis is true and the conclusion is false. So it's false here and it's true otherwise. So these two statements are the same. But the inverse, like this one, okay, let's suppose it's always true that if I walk in the rain I don't get wet. Well then is it true that if I don't walk in the rain I don't get wet? It's not the same. Okay, this is false only on this condition here. Hypothesis is true and conclusion is false. So it's different. And let's suppose that the first statement is always a tautology. In other words, we've ruled out this possibility. It can never happen because that's a tautology. That this could still be false. And that's the case, that I'm sorry, that I'm not walking in the rain, and I don't get I don't get wet, I mean, if I'm walking in the rain, walking in the rain, I get wet. But if I don't walk in the rain, I'm not walking in the rain. I'm not walking in the rain. I'm not walking. I'm not walking. I'm not walking in the rain. If Davis is irrational, then he's all wet. Okay? Anything in the name of science. I guess I shouldn't have bought that at Starbucks earlier today. I should let it warm up, It comes to Starbucks, it's nice and cold. Get it now? Yeah. I was not walking in the rain. Look at me. I'm sopping wet. I can teach better than I can sing, I hope.